Hello and welcome back to a new video here on the Lötig Fusel channel. In this video we're going to continue on our journey through the Boost libraries. Today we're going to talk about the library Boost.Align, a library for memory allocation in a aligned fashion, cross-platform, and with aligned memory allocators for the standard library. Now, first, let's talk a bit about the problem what aligned memory allocation solves. The problem that it solves is that memory gets allocated at random places. Now, memory in general, it is allocated where the operating system sees a free memory spot. This could be everywhere in memory, and it has like more or less no constraint where the memory is aligned. It's somewhere in memory at some certain byte offset. It's going to allocate the memory, and this is then usable for that called malloc. Now, this can be a problem if you are dealing in or working in a constrained environment. For example, if you are working with atomics. Atomic instructions are only guaranteed on certain CPU architectures to be atomic when the memory is aligned. Or some operations like the SEMID, so single instruction multiple data, SIMD instructions on the CPU that are used for like vector math in games. It is also relying on aligned memory locations, otherwise the computations take longer if it's even possible. For example, like loading data from memory into the SSE registers takes way longer when it's done non-aligned. It still works, but I think it's like two fetches and it needs to shift them a bit around to kind of like get them in there. However, if you kind of like load them in an aligned fashion, then it's good. Now, aligning memory is not that easy as you think. There is no like CPP standard, or at least not currently, that supports memory alignment out of the box with the standard. So in the standard, if I do like, for example, a while loop, let's say, oh, come on, I cannot type, okay. There we go, I smaller, let's say 100. If we are doing 100 memory allocations and we are checking if they are aligned. So let's say auto ptr equals malloc, and we are mallocing, let's say 8 bytes or something, or maybe let's do even an odd number to trick the operating system into thinking we are doing stuff. cstd-lib, I think, is malloc. Yeah, there we go. Don't forget to free this. If we are doing it like that and we are checking for alignment, so how can we check for alignment? We can, of course, we need IOStream if I want to use that. IOStream, if we would check for alignment, we could do this by basically checking if the pointer converted to a 64-bit integer. So a pointer is a 64-bit number in terms of 64-bit. If we are taking this modulo, for example, let's say our constraint is 512 bits. Let's divide these by 8 so that we are actually at the byte boundary. And if we are doing a check like that, std-endl, we should get basically a check if the memory is aligned. So if we are now taking a look at the numbers here, we can see that we are getting a lot of different numbers. We're getting like 16, 16, 0, 48, 48, 0, 48, 0, 48, 48, 0, 16, 16, 16. And in the end, what we need is we need it to be 0, because if this modulo operation returns 0, it means it is aligned on these 512-bit bounds. And yeah, as you can see, malloc is currently not fulfilling that goal. You can see the memory is just laid out randomly. We could even make this check even a bit more idiot proof and check that it is 0, and then output something like true or false if it's aligned or not aligned. And if we are wrapping this again in brackets, it's going to work. And now we should get like some true and false outputs if it's aligned or not aligned. Now, if we want to now make this memory aligned, we would need to consider functions that are built into the Windows operating system. However, what we can also do is we can use Boost. We can use Boost.Align .hpp, and if you are including Boost.Align.hpp instead of using malloc, what you're going to go is boost alignment, and then you can say aligned alloc. And if you're aligned allocing, you can basically specify the alignment size 512 bits, and the size is 7 bytes that we want to allocate. And if I allocate my pointer like that, and of course also then don't free it with the normal function, but free it with the aligned free function. If I do it like this, now we should just see truth, because every of our memory alignment is or allocation is now aligned. And if I take a look at this, I only see true in the console. Well, this basically means we now have allocated memory in an aligned fashion. Now, as you can see, this is kind of like raw C-style memory management. However, what we can also do is we can, of course, also let the memory be managed by Boost. So instead of that, let's maybe use the string, right? So instead of having the pointer like that, I want to have a std string that's allocated by that. And what we can do is we can basically create a string with a certain type of allocator. In this case, it's going to be our boost allocator. However, what we need to do is we need to define for that to work our own string type, but our own string type is defined very quickly. So let's call this my string as a type, and my string is an std basic string, which has the element type of char. Then it has the std char traits of type char, and then we need the allocator, which is the boost alignment aligned allocator, and we are allocating characters and we are aligning them to 512-bit boundaries. This seems like a very, very odd line of code, but this is basically how you define your own string types, right? You're gonna inherit from the basic string, which is basically just a container. You need to specify char traits that are used for the char operations, and then you need to specify an allocator. And if you don't specify one, the default one is used. Now, if I now take this one and call this one string, and then I can now take a look at string.data and basically interpret the string data pointer as something. I could even like start and put something in. So for example, hello world, I can put this one in. And if I now check the string data against that, we are now going to use our custom allocator, which makes sure that every of our strings is properly aligned. Just to show you the difference, if we would go for an std string, you're gonna see that we again are going to have actually always false. This is even worse than I would have imagined that. Probably because the way strings are stored, but you can see it's like always false. We are not getting any string, probably because they are reused, but yeah, we are not getting like any string that's aligned. So changing this just to our my string type, we can easily fulfill the certain condition that we have that's aligned to 512 bits by using this boost allocator. And this allocator actually works with every yeah, kind of like class from the standard library. This is how it's designed. So yeah, thank you for watching. See you in the next video. I hope you enjoyed that small excursus into Boost.Align. And yeah, see you in the next one. Make sure to like and subscribe. Have a nice day. Bye.